All right. Is this on? Yes. All right. Hello, everyone. Are you excited to figure out how to write great games for both Windows and Windows Phone? Well, if you are, you're at the right talk. My name is João Haza. I'm a program manager for the Windows Phone Developer Platform Group. And today, I'm going to talk exactly on how you can write and leverage a lot of functionality so porting your games to both platforms is super smooth. Now, I assume you're here because odds are you already have an application, or you're thinking about writing an application, or you already have something in another platform that you're thinking about migrating to either Windows Phone or Windows. You're probably looking at the numbers, you're seeing the increasing market share, you're seeing various reasons where you're thinking about bringing your application over. And you might be asking yourself the question of, which one do I start first? Should I do it with Windows? Should I do it with Windows Phone? Well, there's a collection of techniques that you can leverage, and I'm going to talk about these today, where you can actually write your application in a way that works across both platforms. There's a lot of functionality that you can share across the two. And since the Windows Phone 8 native game development SDK was released, this isn't necessarily like a hidden secret or a hidden trick. A lot of the things that I'm going to talk here today have actually been implemented by games such as Dread vs. Zombies and the upcoming Halo Spartan Assault. So the idea in itself isn't too far-fetched. So when I talk about convergence, what I'm actually talking is about sharing code and sharing art assets. So in other words, how can you have the same set of functionality that you're writing applied to both of the platforms? The value of that, obviously, is that you spend less time porting or writing platform-specific code. And the benefit, consequently, is that you increase your distribution. Users from both platforms will be able to access it, and you get a bigger bang for your buck. Now, when it comes to convergence stories regarding sharing code, there's actually quite a few of them. We can talk about the pure native C++, which is what I'm going to be focusing on this talk, but there's also the managed case for C# and so on. There's a lot of content and samples out there. And if I'm not mistaken, I believe it's Tim Laverty's talk tomorrow on writing C++ applications and C# should be able to help you out on the areas that I'm not going to be specifically focusing here today. Why pure C++ and native code? Because most games are written using these types of technologies, and so I'm going to be focusing on here for now. Also, when we talk about comparison between the phone and comparison between Windows, we need to ask ourselves, are we comparing with the new application storage API surface, or are we talking about the classic desktop space? Well, because aesthetically, in terms of user experience and sample-wise and core functionality, Windows Phone converges quite a lot with the new store application model that Windows has. I'm going to be focusing on this talk on that. So if I don't talk about HWinds and classic desktop components, that's pretty much due to this factor. Now, when we talk about the SDK across the two platforms, we can think of them as a Venn diagram in terms of overlapping functionality, APIs, tooling, where one case when it overlaps across the two, you can use as is, and this is where you truly begin to get the benefit of the converging platforms. Now, obviously, there's going to be platform-specific functionality out there that you're going to have to worry about. But as I go through this talk, I'm going to be highlighting and saying, these are the areas that converge, these are the areas that don't, and here's how you mitigate them so you can write your game. And before I get started on the actual nitty-gritty details, I also need to define the difference between portable code and shareable code. Portable code is when you build a library, such as DLL or a lib, and that gets shared across the two projects. Shareable code is when you have the actual source files themselves being shared across the two projects. Because of the way Visual Studio is set up right now and various samples out there, for this talk specifically, I'm going to be focusing on the shareable code component. So how do you actually set yourself up to share code across both a Windows and a Windows Phone project? I'm going to do a little walkthrough on that right now. So I have here Visual Studio that you can grab, and I'm going to create a new project. I'm going to select the Windows Store, and like I said, we're going to focus on native code development, so it's going to be the D3D application, and I'm going to call this my Windows app. And the solution name will be Converged App. Click OK. And what this is going to do is it's going to generate the default template for the spinning cube for D3D applications for Windows. You have the cube render class, all the good package right there. Now, I'm going to right-click on my solution, and I'm going to add a new project. And in this case, I'm going to add the Windows Phone project. It's going to be the pure native one as well. I'll name this my Windows Phone app. And here I have, it's the same equivalent template to both Windows and Windows Phone. It's the spinning cube one. But as you can see in my solution, I have both my Windows app and my Windows Phone app. Now, to actually share code between the two, I need to specify a common folder in which both of them will be able to have visibility for the actual source files. In this case, and for the rest of the demos, what I'm going to do is I'm going to have the Windows Phone application gain visibility into the Windows application folder itself. To do that, it's quite simple. Right here, I have my converged app folder, which I just wrote. I'll head into the Windows application folder. Here are all my source files that I just created. I'll grab this path, head on over to my Windows Phone properties, go to the C++ directory, and right here you see the library directories. If I include this folder in my library directories, now my Windows Phone application project has visibility to my Windows application project. What this enables me to do is I'm going to create a new filter where I will call it shared, and basically all my shared code is going to exist inside this filter. I'm going to create, as an example, a new header file, which I'm going to call shared header. And I can just add, shared code right here. But this is just in my Windows application project. Let's do the same for my phone application project. So what I'm going to do is I'm going to right-click. I will, for convenience sake, I'm also going to create a new filter called shared. And in this shared folder, I will also add an existing item. In this case, I wanted to point to the shared header that I just created. And right here in my Windows app folder, I should find my shared header, which is right here. And as you can see, as I'm altering my shared header in one specific project, I alter on the other one as well. In this case, as you can see, it's the same file that's being interacted, and if I compile each project subsequently, I'll be able to leverage that. Now, this example that I just highlighted, where I have a Windows Phone and a Windows project with a shared folder across the two, is the same template that I have for the rest of the talks. But I think if you get the idea, you can customize this overall experience to whatever build environment you have. Let's go back to our presentation. So that was the Visual Studio walkthrough. Now, when it comes to actual platform requirements from games expect a lot from both of the platforms. And for each one of these boxes, my goal for the rest of this talk is to highlight how you write convergent code across graphics, audio, input, and so on and so forth, highlighting the discrepancies between the two. And for funs, I'll have graphics, audio, and input samples highlighting real-time how you can actually do that. So let's get started, shall we? Graphics. Well, if you're writing graphics APIs, I have some quite good news for you. D3D, DXGI, DirectX Math, which is the functionality used in most native game applications out there, converges quite a lot with both platforms. So if you write code specifically in terms of loading assets and submitting to the GPU, shaders, etc., there's actually quite a lot of convergence here that you don't need to worry about. The specific discrepancies is Windows has D2D, D-Write, and WIC, which are commonly used for GUI types of rendering in-game applications. But if you want to have a common functionality in terms of GUI programming, what we suggest is you could use the Visual Studio Starter Kit or the DirectX SDK, which are freely available on Codeplex. You can go there and download them. And these SDKs work across both platforms. So if you are not interested in, for example, taking independence on D2D, that's actually one of the ideas. Now, I talked about the APIs, but obviously there's discrepancies in the hardware itself, how the GPU functions, what kind of shader levels access you have. The D3D11 API set, which is shared across both functionalities, it defines what's known as a feature set. A feature set is basically, you can say, this machine has a 9_1 or 10_0 feature set, and it dictates what's going to be your maximum texture resolution, the number of pixel shaders instructions you can have, what kind of access in the pipeline can you program, and so on and so forth. The list is quite lengthy, and it's fully available in MSDN, but if you are interested in writing code that's compatible across both platforms, if you write your game logic in terms of graphics capability that can scale down at least all the way to the 9_3 feature set, you'll be able to have shareable code across the two platforms. Every single Windows Phone 8 device out there has at least the 9_3 feature set, but if for some odd reason you still want to have even lower requirements, such as the 9_1, you still have that accessibility. Now, let's have a graphics demo highlighting how that all comes together. What I'm going to do is I'm going to load up here a D3D sample application that I have written. I don't need to save this for now. And what this D3D application has is a special class that I wrote called the mesh renderer. What the mesh renderer does is quite simple. It loads a .object file, which is the classic 3D mesh format out there. It contains a list of vertices, contains a list of faces, and you just utilize that to do your rendering. And the mesh renderer basically loads that data up and then renders it. So the aspect of actually loading the .object file is mostly contained here. Don't worry about most of this for now. But basically, as you can see, it parses the data inside the object file. And here's the key part. As you can see, I have a vertices array. And I also have an indices array that I'm just reading the file and just populating these both arrays with this data. Now that I have right here below, right at this step, both my vertices and my indexes filled up, what I need to do is write the code where I can actually set it up and pump that to the GPU so we can render. So let's do that right now, shall we? But to do that, there are 3 steps. One is describing what the data is going to be. Second, how big the data is. And then actually creating the buffer itself. So let's describe the data. First, you do a D3D sub-resource data. And I'm going to have a vertex data right here. And the vertex data structure has 3 parameters. In this case, the first one is just the system memory, which I'll describe as my vertices, which again is exactly the same array that I was reading my vertices data into. And the other fields in the vertex data array, they're not necessarily used in this specific example. I'll just set them to 0. All right, so that's the vertices. Let's do the same for the indexes. And it's exactly the same. Sub-resource data, index data dot.psystemmemory. I'll set it to be the array of indexes that I have. Now, like the vertices, the other fields aren't used, so I'll just initialize that to 0. Okay, so now I have a descriptor of what the data is. Now let's have the descriptor of the buffer itself, which basically encompasses what stage in the pipeline and how much space it'll consume. To do that, I need a D3D11 buffer, descriptor object. And I have my vertex descriptor, and whose first parameter is the actual size of the buffer, which I just conveniently pre-calculated here, how big the vertex buffer is going to be. And then I pass in the flag, D3D_bind vertex buffer, which basically means this buffer is going to be bound as a vertex one. I also need an equivalent one for my index descriptor. So size of index buffer and bind index buffer. There you go. I've described the buffer, in what data specifically do I have. Now that's actually loaded up into the GPU. To do that, we use our handy D3D device object. We call create buffer. And we pass in the 3 subsequent parameters. So in this case, it's my vertex descriptor, followed by my vertex data. And then the third is the actual D3D vertex buffer object, which is part of the class itself. Let's construct the same buffer now for my indexes. So my index descriptor, my index data, and then my m_index buffer, which is also a D3D object. Now, this new guy that just showed up right here, this is basically my D3D buffer object, which, as you can see in my render function, is exactly the one that I'm using to set in the vertex buffer, calling draw, and so on and so forth. So I loaded up the file, described its data. Let's take a look at how it looks in our Windows simulator. And basically to compile, deploy, and as you can see, I have my little human object just spinning around as a mesh. Now, I just did that on my Windows application project, right? How do I do that on my phone? Well, what I didn't tell you before is that I had already previously set up my mesh render class to be shared across the two. And everything that I just wrote here, I also wrote on my phone application project. This vertex shader and this data easily falls in within the feature set 9_3. So I'm not going to change anything. I'm just going to deploy to my Windows Phone emulator. And let's take a look at the results, shall we? And it's exactly the same. Same code, same asset, being shared across both functionalities. Thank you. So that was the graphics. Let's go to audio. If you're thinking about using audio native functionality, I have good news. There's a ton of stuff that you can share. Xaudio 2, Wasapi, the geo-positioning, not the geo-position, the 3D positioning aspects of audio, you can all leverage that. Media playback functionality converges across both platforms. There are two specific edge cases when it comes to audio programming that I'm going to highlight here today. It doesn't really touch most game scenarios, but nevertheless, one that's specific for Windows is if you want to extract the PCM samples of the actual audio file that you're reading via hardware acceleration, that's only available on Windows. And on phone, being able to play an audio sample via the Media Foundation APIs via hardware acceleration, you can only have one at a time for various, chassis constraints and so on. If you want to play more, levels of sound, effect, and so on, you can always overlap them using Xaudio 2 and so on. But keep in mind that utilizing hardware acceleration on phone, you only have one instance. But the rest, like I said, it all just converges as is. Let's have an audio sample then, shall we? Explaining how that all maps together. So what I'm going to do, I'm going to open my audio sample. And my audio sample, what I have here is I already have set up to be shared my jukebox class. And what my jukebox class does is quite simple. It just loads up a WAV file, extracts the PCM samples via software, and then pumps that through the Xaudio 2 engine. So this is the WAV file that I have shared across the two. And in this section right here is where the jukebox gets set up. I create my Xaudio 2 object, I create the master voice, the sound file reader is a class that I wrote that basically extracts, like I said, the PCM samples of whatever I sent it through. And basically down here, I'm at a similar stage to my graphics where I have all the data read. Now I need to pump it through to the specific pipeline. To do that, I use my handy source voice object. And I'll stop whatever was previously being played because I don't want any distractions. I would like, for example, the specific sound to be the only one being played. Now let's flush whatever was already there so I don't have any stalls in the pipeline. I will now say this is the actual buffer of PCM samples. As you can see here, I have an Xaudio 2 buffer descriptor where I basically highlight this is the length, this is the data, etc. And now that all that is set up, let's play the song. And if start 0, let's take a look at how this functions on the emulator. To compile, and you should hear a nice handy helicopter. Now, the code that I just altered, for example, is, like I said before, is also being shared on my Windows Phone project, the Jukebox class. I'm not going to change a single line of code, and I'm just going to deploy to my Windows Phone emulator. There you go. Same WAV file, same code, being shared across the two, playing similar sound effect. Now, That was audio. Let's move on to input. Regarding input, there's a lot of functionality that also converges across the two, such as the events, the states, the type, and the frequency. And the display request API, it's not really an input-related API, but if your game is going to present, like, for example, a cutscene to the user, or the user is not going to be interacting specifically with the device because you're just displaying something to him, you can use this API to say, hey, don't turn off the screen while I'm doing that. So both this API functions across the two platforms. This might go without saying, but Windows Phone doesn't have any mouse wheel or mouse APIs functioning on it. And if you are interested in using gesture recognition APIs, then in this case, what you're going to have to do is leverage the managed stack for that, or utilize a hybrid application model to be able to leverage that. Windows Phone 8 has part of its chassis specs the back button. We have a few APIs for you to be able to control that. And the SIP, which is the virtual keyboard that the user sees as he's typing, both application model platforms grant you access to it, but for now they have a different set of APIs. Let's have an input demo, shall we? Where I basically describe that. And what my input demo is going to be, project solution, input sample. Now, my input sample is exactly what the mesh rendering graphics demo you just saw. It's basically the human object just spinning around. And what I'm going to do is I'm going to alter it so it actually moves based on the input of the user. To do that, I have here on my onPointerMoved function, which is basically a function that's pre-built for any D3D native application model, both on Windows and Windows Phone, so you can start coding as is. And to be able to move my mesh based on my mouse's movement, I need to basically calculate a delta of where it was previously at and where it is right now. To calculate that delta, let's create a static local variable called previous x position. I'll initialize it to 0. Let's create the delta class itself, which in this case is going to be args, and get the current position. Whoops. Current position's coordinates x, and I'm going to see the gap between the previous position. Because we obviously need to keep track of this as time progresses, I'm going to make the previous position equal to the current position. And now, once I have this data, I'm going to call my renderer object. Again, the mesh renderer is the class that actually loads the mesh and renders it. In this case, this is the object that the game instantiates to actually do that. And I'm going to call increase rotation, sending as a parameter my x delta, and I'm going to multiply it by a percentage to attenuate. What the increased rotation API does is relatively simple. It just increases a local variable in my mesh class called mRotation by whatever factor I added. And what I'm going to do is, you were seeing that the mesh was rotating over time. I already have it here previously. Well, it was like this before, where it was utilizing the time delta to actually rotate the model view matrix for the mesh. And what basically I'm going to do here is I'll change it for the actual rotation object of the mesh itself. I'm going to compile, and let's see the results. All right. So now here I have my mesh, and as you can see, it's clearly moving based on the movements of my mouse. It's no longer auto-rotating over time. The source code that I just changed is exactly the same one that I already previously set up to share with my Windows Phone application. Let's debug on our Windows Phone emulator and see the actual end results, shall we? So here I have my mesh. And you see it's also rotating using the same functionality. Now, that was input. Let's go to the rest of the API surface area. The application lifecycle, basically starting the application, deactivating, suspending, resuming, core window application model, etc. Those two converge. One thing I would like to highlight, though, is the suspended is when your application goes into the background, the OS sends your application the suspended event saying, hey, you are no longer in the foreground. Your application needs to respond to this event because if it doesn't, the OS assumes you might have deadlocked or reached a faulty stage, and it could potentially kill your application. If the OS, in this case, on average, the Windows OS expects your application to respond to the suspend event in around 5 seconds, while on phone, around 10 seconds, because you don't, on phone, you don't have as fast of a chassis, you might not have as much as memory, but the actual events themselves are there. Just keep in mind there's a slight discrepancy. Windows 8 also have various other mechanisms for you to activate your application, such as via sharing, search protocol, and so on. And although this isn't really an application lifecycle object, the drawing surface background grid, I still want to highlight this because the drawing surface background grid is the Silverlight control that you leverage in order to do interrupt between managed to native. If you do use the drawing surface background grid, keep in mind that most of this native functionality, such as core window and so on, you won't be able to leverage. So that's why it's on the phone-specific category there. But if you are going to write a pure native core window application, in other words, what's right here, you should be good to go in terms of convergence. CRT, the C runtime. If you pick any learn C, C++ book in 21 days or how to learn C++ programming, you're going to basically learn the C runtime. It's all like loading files, fopen, STL, cin. It's about 3,000 functions in total. And the good news is that it all converges across both platforms. There's no discrepancy. Storage APIs, if you want to, these are the Win32. If you want to create a file, load it, delete it, enumerate folders, and so on, converges across the two. The one that's specific for Windows is the file mapping APIs. And most games, at least on mobile, aren't necessarily impacted for this, because file mapping storage APIs are generally used for streaming textures or loading files in an asynchronous way. But most mobile applications where we've seen so far don't necessarily rely on it. But if you do use file mapping APIs on Windows, keep in mind it's Windows specific. The WinRT storage APIs also converge quite nicely. You have access to the local folder, the install folder. You can utilize URIs, data reader, data writer. Now, what's specific for Windows is 3 sets of folders that you have access to that doesn't exist on Windows Phone 8. The roaming folder, think of it as a virtualized folder where as you're putting content in one specific location in the application, if you have another Windows device with this running the same application, they'll be shared across the two. The temporary folder is not really useful for most games. It basically means you have this place where you can store content, and if the system is low on memory, the system will just wipe clean whatever's there. And the known folders is where I have access to my pictures, my videos, and so on. But just because the known folders is Windows specific doesn't mean you can't have the same scenario on phone. If you want to have access to the My Pictures folders on phone, you can. You're just going to have to use the Photo Picker launcher. And basically, via these two, you can pretty much do the same set of scenarios across. Sensors. Pretty much all sensors just converge, and these are the ones that tell physical details about the device itself. Obviously, everything but the accelerometer is a part of as an optional in the chassis. So what you should do is check if it's there, and if it doesn't, or if it is, follow through accordingly. The only one that's Windows specific is the light sensor, which basically tells the light intensity surrounding the object. But I haven't seen a lot of games use that, if any. Now, one thing that's specific for Windows Phone 8, though, is not necessarily a sensor, but constraining the distribution of your application based on hardware chassis. So for example, let's assume you're writing an application that uses the compass, like a location application or a location-based game in which the compass is absolutely critical. If the user doesn't have the compass on his device, it won't necessarily work. And you don't want to have to check and see if it's available and have a dual test matrix, etc. You just want users with the compass to be the ones who get that. On Windows Phone, you can do that. You can basically say that only users with compass gain visibility of your application when browsing the marketplace. What you do is you go to the Windows Phone project, you right-click on your application manifest, go to View Code, And right here below the screen resolution, you just add a new tag called the requirements tag. And you can concatenate as many as you want, but by adding, for example, a new requirement, I can say ID rack magnetometer. And what this means is if I publish my application with this manifest, only devices with the magnetometer, which in this case is what powers the compass, will be able to have visibility. But then again, that is only if your application is crucial. We still suggest that you try to scale down or try to still have as much broad and reach for our end users out there. So that was the sensors. Location. It all converges as of Windows 0.1. Platform-specific area. There are some areas, though, that are easier to describe as platform-specific than more converging. And in this case, I highlighted them here all at once so that you can take a view. So some of those areas they're a little bit platform-specific because of the form factor or the actual way in which you leverage them or specific to that platform. Or others you can only access, for example, in the Manage stack on Windows Phone. So these are all signed up right here for you to view. You have access to them, but just keep in mind when it comes to sharing code, these are one of the cases that you need to look out for. Now, I talk about the API surface area. There's also another factor that you should keep in mind, which is the actual size of your application as a distributed app in the marketplace. Updating on Windows 8.1, the application size for limit is 8 gigabytes, while on Windows Phone 8 is 1 gigabyte. And obviously this discrepancy is because you have Windows Phone devices out there with lower memory and out there in mass reach markets. But historically, just keep in mind that this is a discrepancy that you can have. The other aspect is that when it comes to runtime, the Windows Phone runtime to how much memory your application can consume hard caps it to a specific bound because you can have devices out there that might not have as much memory out there. But the good news is if you're writing your application the right way, you're going to keep in mind the memory consumption of your device. And if you build it in a way that scales for phone applications, it will easily scale up to the rest of the Windows apps. And if you are interested, basically what you have in Windows Phone is an API that tells you how much memory you can have and how much memory you have right now. And based on this gap, you can then assess at runtime what to do. So say, oh, I still have a bunch of memory left, load the higher assets, ART assets, and so on and so forth. Now, before I finish, there's still quite a lot of content out there. I think I just scratched the surface when it comes to convergence across the two platforms regarding native. There's still a lot of the C# space. I highly recommend you checking out tomorrow's build samples. I believe Matt Hardring will have another focus on convergence across the two platforms. Last year's build, there's a lot of stuff there, and our docs team does a great job in providing samples in the space. Now, you might be thinking to yourself, yeah, sure, it all sounds simple and in theory, but in practice, it's not that simple. So to finish this, what I did is I constructed a demo that just encapsulates all of that. I built a very simple game. And yes, this game will not win any international prizes, but it's something that I built in an afternoon, keeping in mind the design and all of these things that I just explained to you. And it's something that I believe 90% of the source code is just shared. And I didn't write, okay, let me write the Windows, and then let me write the Windows Phone. I just wrote it, and it just worked across the two and just did. Now, keep in mind, again, it's a simple game. But let's take a look at it, shall we? So I'll just open up here my game demo. I don't need to save this. So here on my Windows Phone, as you can see, I have quite a lot that's already shared. My D3 base, my game, loop object, my shaders are also shared, my sprite class, TJ Reader, the whole spiel. So let's launch. And I have here my little warrior sort of fleeing as the oncoming waves of hordes of enemies, try to attack him. And he has to die. But if he doesn't, dodge and he gets eventually caught by the red goblin, he dies, but he comes back to life. And the entire game logic, the only thing I changed mostly was the viewport location of the actual game itself, and the rest is just reused as is. Let's take a look at how it looks on my Windows Phone emulator, and it's exactly the same game. You know, the little guy running away from monsters and so on and so forth. And if the red goblin catches him, he will also die. And basically, oops. And that's basically the game in itself. Thank you. All right, so that was my talk. Before I finish, please out the event evaluation forms. This is actually a great method for us to get information. Thanks a lot for your time. And for questions, I'll accept them now. And whoever asks the best question gets a brand new Windows Phone 925. So I raise the challenge to you all out there. Thank you. All right, do we have any questions? Is anyone interested? No? Can I keep this? Yes. Good question. The question was, did I use any third-party tools to migrate the code? No. I wrote everything. Okay. Any other question? Yes. Okay. Okay. All right. Thank you. That's a great point. The reason why I'm repeating is so that we can record it as well. The question is, why don't we have a wizard for actually setting all of that up? It's actually a great idea. I'll talk with the docs team on this aspect, and because we already have samples on how it can set up, and the intricacies about sometimes wizards is like, as we talk with various game developers, they all have their own particular build environments. It's kind of like difficult to have one that just works across the two. But for example, if you're interested about learning more about that, the Marble Maze sample, if I'm not mistaken, already leverages a lot of content across the two platforms, and it's a great way for you to, get started. A few developers that I talk to even use the Marble Maze application and start modifying for their own game. I'll get your second question soon. Yes? Good question. The question was, do third-party convergence tools like Unity enable you to support, convergence of code? If I'm mistaken, Unity allows you to edit code as you want. If you should be able to have a lot of convergence in this space by keeping in mind these various aspects. It's really up to the actual middleware in terms of exposure and like which application life model if they're using. Like I highlighted, if they're using the drawing surface background grid, it actually impacts, for example, you won't have access to core window, and with that you won't have access to various other implications and so on. But for example, if you want to write sensors code, such as the accelerometer, which is shared across the two, if you want to write CRT code or storage code, etc., and this middleware providers allow you to somehow hook into that, like you construct a library or DLL with loads at runtime, then you should still be able to leverage these techniques as well. So you are as blocked as they allow you to be in that case. Any other question? Yes?
Your slides showing the differences were very interesting. I remember about 2 or 4 months ago searching all over the sites trying to find something like that. Do you know if that is now some kind of
Oh, yes. So the question was, are we going to have this up for sharing for developers like yourselves? Yes. We don't have now yet, but I'm working with the docs team to actually get that published out there.
Yeah, I'd like to see
Oh, forever? I think the premise is pretty much all the samples that are being presented will eventually be up for grabs. I think it's just a matter of time before cleaning up and getting granting permission, but eventually, like this one specifically, I'm working and it'll eventually be there. All right? Yes? Will Windows Phone also support WebGL? Windows Phone 8 doesn't currently support WebGL, and I'm not really of any liberty to talk about future plans. WebGL on Phone 8, I'm pretty certain it isn't supported. So, yeah. Yes? I'm sorry, I didn't understand. Do you mind speaking a little? Yes. The question was, have I seen the case in which someone utilized not the Visual Studio aspect, but like some sort of build server where the code was commonly checked in and that produced both the Windows and the Windows Phone? I have seen a specific developer leverage the command line tools that are available with Visual Studio to do that. I don't know the full extent though. I have heard offhand about a comment on them being able to leverage that. If I'm not mistaken, the docs team on Visual Studio are planning on releasing a few documentation on this specific area. I don't know when though, but it's one of the common requests we get. Anyone, another question? Yes. Oh, yes. The question was when you're playing a game where a phone call comes in or something abstracts the user interface, and once that's gone, can you make it fluid and so on? On Windows Phone, you can. There's an API, if I'm not mistaken, it's the Window Obscured API. And basically when a toast or a phone call comes in and so on, you can listen to that specific event. And then it's up to the application logic to do whatever you want based on that. If you can, for example, pause the update of all your game loop logic, as this event is ongoing, you could do that, or if you want to unload or preload things, it's up to the application. But I think we do expose sufficient information, obviously like suspending, resuming, and all that context, so your application could respond and be as smooth as possible. Okay? In Windows 8, it's called visibility change, yes. Yes? So the question was toolkits that make it easier for you to share code. Ah, I see. Well, go ahead. Well, which specific extra mechanism than what we just highlighted? Oh, I see. The Visual Studio Starter Kit that I highlighted, for example, possesses a lot of the content, if I'm mistaken, content pipeline that XNA used to have. So, for example, if you want to load meshes and various textures, etc., it actually possesses that. I think your question, in the broad sense of, is being able to leverage, codes that make it easier, not just for the life cycle, but also like the overall pipeline of like, oh, I'm loaded. Let me load the specific files. And like I'm unloading, let me unload the specific files. In this case, I think it's more of a middleware question, where it's like each one of, for example, Unity and Marmalade and all those guys, they actually have these internal hooks. If you're more interested in the middleware aspects, sadly right now was occurring a middleware talk by JC stuff, but it's being recorded. So I would recommend you take a look at it and see if that actually addresses your question regarding middleware and which specific sections you're looking for. Oh, good question. So the question is, what do I advise for actually writing shaders in a converged manner across the two? Well, Windows Phone 8 has, like I said, access to the 9_3 shader access, which pretty much grants you access to the pixel, the vertex shader. I know for a fact you don't have access to the geometry shader. I can't recall if you have access to the whole tessellation domain shader. I need to look that up. But basically is if your specific shader is able to map to the underlying feature sets, because you also need to include things, for example, the number of instructions your shader has, which kind of instructions specific your shader has. If you are mapping to the 9_3 set, and MSDN has this giant table that just has all of that, and if a shader developer leverages it, then you should be good to go on that front. Okay? You, yes. I'm going to be fairly honest with you. I don't know about the Xbox API surface. I honestly don't. So I don't think I can really provide any particular insight into the space. My apologies on that. Oh, he said we have a talk on Fridays focusing on that. So I recommend you take a look at that specific talk. Shaders have to be precompiled on Windows Phone 8. If I'm not mistaken, yes. They also need to be precompiled. You cannot have runtime shader compilation on Windows Phone 8. Yeah, correct. I don't. Sorry? Let me just get to the rest of the questions and we'll sort that out. You, yes. Sorry? Is it possible to have XNA in Windows Phone 8? Yes, XNA, you can have an XNA application working on Windows Phone 8. As a matter of fact, all the XNA applications that were published in 7.5, we did a lot of parity work to actually make sure that it worked on Windows Phone 8. So I don't think you're necessarily blocked on that front. Are we getting kicked out? Yes, we have microphones there. Didn't even notice that. So if you have a question, just stand up and I'll ask, so everyone else can hear. Yes, you.
Hi. Can you give any recommendations for sample projects on networked Windows Phone apps for direct head-to-head competition?
Specifically on networking, sorry, I was supposed to say during the talk, but I forgot about it. Tomorrow, Peter Tor is going to have a networking talk. And he's going to focus on networking. He's going to talk a lot about convergence. The reason why I didn't focus specifically on this one is because since he's doing an entire talk on it, I tried to talk on the other aspects that weren't overlapping with someone else. Okay?
Okay, perfect. Thank you.
All right. Any other questions? If you have, please go to the microphone. I was asked, sorry.
So my second question is, can you have a mixed mode game where you have managed code and your native code in Direct 3D? And can you overlay SAML animations on top of your Direct 3D renderings? Say you have your 3D modeling in DirectX, and then you can do your menus and stuff on top with SAML, which is easier to do.
Yes, you can. You can absolutely do that. By using the drawing surface background grid, which I discussed, you can literally do that. You can have a managed and native code application. You can have your native application being overlaid with XAML controls and so on. Via this method, you can also access the other managed APIs that don't have access on the native realm. So you can do that, yes.
Can you do translucency too?
I believe so, yes.
Okay, cool. Thank you.
No problem. Any other questions? Yes, you.
Just one. I was wondering, with Windows Phone development, is there any differences, like when inspecting like device capabilities?
Windows Phone development differences in device capabilities?
For the direct libraries themselves, for like the different resolution sizes and whatnot.
Oh, so basically, in terms of every time there's a chassis variability somewhere, that API, that scenario is usually accompanied by APIs that allow you to query. So the specific example that you highlighted, such as the device resolution, you can actually query and say, what's the actual size of application? And if I'm not mistaken, you get that via the core window application class, which is actually converged across the two. So, for example, also the sensors, where it's actually optional chassis. You can actually query to see if they're available as well. Or low-end memory devices. You can run a simulator that has 512 megs or a simulator that has 1 gigabyte device. So there's various knobs and twists that you can leverage regarding that. If you're more interested for more information on that, I suggest looking for samples on the manifest for Windows Phone 8, because recall the requirements section where I said, oh, you can actually add this magnetometer, tag and so on. The manifest contains a lot of these things, and just learning more about that allows you to see the various configurability of devices out there on the wild. Okay? Any other question? Yes?
Question. So I wanted to say I think your examples were compact and really impactful.
Thanks.
I think the one question for me is maybe for non-Xbox Live enabled games, do you have any recommendations for being able to like save data between the two? So game preferences or save data?
Well, regarding saving data on the game itself, both Windows and Windows Phone grant you access to the isolated storage of the application itself. And in there, you could utilize the data reader, the data writer. If you're doing a managed or native hybrid application, you could use the ISOstore APIs. Basically, it's just it's up to the application logic on that specific realm. The only caveats would be knowing which folders exist on Windows that doesn't necessarily exist on Windows Phone, but the local folder itself is something that you have access. And like the code that I had on the mesh rendering was basically that. The human object file was in my installed directory, and then I just said load that up as it is, utilize the same API. Okay? Yes?
This isn't really a question, more of an answer to the two guys who are asking about managed code and XNA sharing across Windows 8 and Windows Phone 8. I'm one of the devs of Monogame, which is an open source implementation of the XNA API, and that sort of delves into what you referred to as the fully managed code sharing.
I see.
So that's one thing that the two guys who are asking about XNA style is look up Monogame, and that allows you to do the same.
All right.
Code sharing.
Thanks for the info. Any other questions? All right. Oh, yes.
The store submission process for both the platforms, like Windows Phone and Windows.
Sorry, the question was the tools?
The store submission.
The store store submission is not unified. So you'll be able to share your code and be able to produce your app, but once you actually have both your Windows and your Windows Phone application, you need to submit to the corresponding stores to actually get that through. Okay? All right. Yes?
One more. Since we are trying to share code between huge resolution tablets and small phones, is it also possible to create different assets? And is there any aid that I can reuse it easily? So some kind of naming convention, this image is huge and it's underscore, I don't know, HD or something like that. And
yes, you can. There are various ways in which you could have these assets. So like, if you allow me to get your question, is can I have different assets for different versions of my application and so on? And the answer is yes. For example, on Phone 8, I believe you can have different types of assets for different types of locations to comply with various requirements. Based on the version of your application, if it's like Windows Phone 8 or 7.1 or 7.0, you can have different types of textures or assets themselves, or even game code itself, to be able to target if there's a specific quirk or aspect you're interested in. I believe Windows has the capacity for you to do these things on Windows 8. I don't recall right now how, though. If you give me your business card, I can try to get that information for you. Okay?
Thanks.
All right. Yes?
So a gentleman talked about like loading and saving games regarding Windows and the mobile phone. Is it possible that when you load and save a game on the mobile phone onto the cloud, is it possible to use the same method to load it back on the Windows?
Well, it certainly is possible. There are various ways in which you could leverage that functionality. If, for example, let's assume you have your own server, you could utilize the networking APIs that converge across the two spaces and just submit that information up to your cloud and be able to have this discrepancy between the users. Out of the box, I don't believe there is something that you can just say, hey, here's the special folder where all that magic does for you. But I believe there are middleware vendors that actually do fulfill those specific requirements. Which one specifically, though, on phone, I can't recall right now. But this is like one of the spaces that, in terms of platform support, we don't have. Okay? All right. Any other questions? Okay. So they only gave me one. I apologize. So the winner is to the gentleman who asked the question regarding being able to leverage command line tooling in Visual Studio. It's a fairly complicated aspect into it, and it's like one of the areas of my passion. So here you go, gentlemen. And with that, thank you all for your time. Appreciate it.